Hello, this is Bhupendra Patil. This is a simple example of explaining how you can store intermediate results when using optimized parameters and then retrieve them later to find the best model and the best performance in a separate process. A typical use case for this would be if your processes are long running and if they fail in between, then you don't want to restart the whole process from scratch. So you can save the intermediate results here and take actions later on. A very simple use case here. I have the golf data set. I'm building a decision tree model inside. So if I double click, you'll notice there's a validation step. Instead of that, I have a decision tree operator. And I'm trying to validate the model and trying different values of the maximal depth parameter. I'm setting the various combinations to try in the optimized parameter settings here. My decision tree depth value goes from 10 to 100 in 9 steps. Thereby Rapidminer actually evaluates model at all these unique values and then compares them and delivers the best model. But the goal of this particular exercise is we'll optimize and then store those intermediate models. To store them uniquely so that they don't overwrite, I'm using a macro here with the value percentage depth. And the way that I calculate the depth is using the generate macro function. The param function lets you provide the operator name and the parameter name and sets the macro name of whatever the value of that parameter is. So by doing this, after every iteration, my macro has the value of the depth that was tried, and the store saves it as dt underscore 10, dt underscore 20, so on and so forth. And over here, I'm saving the performance, which comes from the AVE port, and I'm saving it under performance slash dt underscore depth. When I run this process here, Rapidminer obviously goes ahead and builds the whole workflow, and you will notice there are 10 different models or 9 different models under the models folder and various performance vectors in this case. Now in your case, if this process had failed in between, it will ideally just stop it at a location where it failed. Thereby looking at the folder, you are aware of where the process failed. So the next time you can iterate from, let's say, 50 or 60 or wherever it failed, thereby not necessarily doing the first 4 or 5 iterations if they were successful. Now the second part of this process is obviously to find the best among this. To do that, we'll build a similar process. I have a pre-built process here that we'll quickly look at. The process is something like this. I have optimized parameters grids again. Instead of that, I have 2 steps here to get the right macro value. The first one sets the macro called as depth, and the second one generates a new macro from that depth underscore string, getting the string value out of it. The reason for this is this macro would be set by the optimized parameter grid and would be an integer, and thereby it will be represented as 10.0 or 20.0. Thereby we just need to get the string part of it. That is what is happening here. Now once we have the string representation of the macro, I'm using that to retrieve the models from the model folder and the performance from the performance folder. And the one additional step here is in the optimized parameters grid, I'm saying for the set macro step, set the macro value between 10 and 100. Now this is the whole grid search that we use in the first process, that was the run optimization. Thereby Rapidminer will set the macro values to 10, 20, 30, so on. And each time it retrieves the model and the performance and compares them automatically. That's what the optimized parameter grid does for us. By running this process, basically Rapidminer is going to use the performance that were pre-created and then deliver the appropriate model that was delivered. So if I run this at this point, you'll notice it delivers the decision tree and the performance vector, which is 65%, which is the most accurate among what we had in the performance folders. So by combining these two approaches, you could build your models, you can run the optimization. Even if it fails, you have the ability to restart in between, and then you use the find best process to find the best of the saved models. Obviously in this case we are trying to optimize only one parameter. In your use case, if there are multiple parameters, you will have to add additional steps here. You'll obviously add the additional parameter that you're trying to optimize. You'll have additional generate macro here to get the value, and then probably you'd be using another macro in the name here to save it with the appropriate name. Hopefully this helps you with the ability to divide and conquer this long running processes sometimes which may fail. Thank you.